Hello, my Algebra 2 students. It's Unit 11 time. So exponential functions is what we're looking at. We've just been talking about exponents in general. If you look at the rundown of the unit, we are going to start with graphing today, and then we work our way through some algebraic stuff later on in the unit. So flip it all the way over. You're going to need your calculator. It's saying a little intro to exponential functions. Well, you've already seen some of this from Algebra 1. So an exponential function just means that it's an equation in the form of y equals b to the x power. B has to be greater than 0, and it can't be equal to 1. Because if it was just 1 to the power, it would just stay 1 the whole time, and it wouldn't fit the pattern that we're going to build right now. So a couple things. The b value, that's called the base of the function, and then the x is your exponent. So an exponential function means the variable is up here, whereas the base, this is going to be a constant value, like a 2 or a 3 or 4, that type of thing. All right, in terms of the calculator exploration, it says we're going to use our calculator to find the missing values, and then we're going to sketch. Something that you're going to want to do here is it says we want to use the ask feature. So if we go into second and then window, so I'm going to slide this up so you can see a little bit better. So if I go second, window, it's on auto right now. I'm going to change the independent to ask. So when you do that, it should be highlighted on ask, hit enter, and then you can quit out of there. Now, if I go into y1 and put in 2 to the x, so go into your y1, if there's anything in there, get rid of it. And raise this, or make it 2 raised to the x power, just like that. If I go to my table, there should be nothing in there because we haven't asked it anything yet. All right, so it's second, window, and then you're going to change the first thing to ask. All right, what we're going to ask it now is these specific values that we want. So when x is equal to 0, y comes out to be 1. When x is 1, we get 2. When it's 2, it's 4, which makes sense because it's 2 to the second power. Put in a 3. Well, 2 cubed is 8. Put in 4. And we can do that for all the values in the chart. Now, something to keep in mind. We are not going to be able to plot all of these values. We just want to look at like what's happening. So a couple things might catch your eye here. When I typed in 30, I got 1.07E9. That 1.07e means 1.07 times 10 to the 9th power. That is scientific notation. So you might even want to write yourself a little note off to the side. Maybe I have some space up here. I can fit it in. So when I see 1.07e9, this is the same as 1.07 times 10 to the 9th power. So that's just scientific notation. If I think about that number, I'm going to be moving the decimal place to the right 9 places. That's just a really, really big number. So if you want, you can write it down as 1.07 times 10 to the 9th. That's perfectly fine. All right. And now if we type in a 50, it gets even bigger. 1.1 e to the 15th. So 1.1 times 10 to the 15th power. So what that ultimately should mean to us is the bigger the x value gets, the y value is getting really, really big. It's heading off essentially towards infinity. All right. Now on the graph, we're only going to graph from -10 to +10, and same thing here. So I can at least plot, 0, 1, 1, 2, 2, 4, and then 3, 8. And then the rest is sort of just showing the trend. Now let's do the negative half of it. So let's type in, -1. That gives us 0.5. If we type in -2, that gives us 0.25. And then -3, 0.125. And what's going to happen is those values are getting smaller and smaller, but they're still remaining positive numbers. Oops, I hit something weird there. Let me go back. All right. Let's see. And now if you start to run out of space, you can type right over the top of the last thing you had. So it'll just change. So I get 9.8 times 10 to the -4th. All right, let's see if I can finish the last two. -30 gives me 9 times 10 to the -10th. And then negative 50, that gives me 9 times 10 to the negative 16th. All right, for the sake of this, think of this one, the 9.8, and then moving that decimal place 4 to the left. So 1, 2, 3, 4. It would end up being really small. It's just this tiny little decimal, 0.00098. This next one, if I take it and move it to the left 10 places, I think I counted 10. Think about what's filling in all those blanks there. It's just a bunch of zeros. So if you were to round this is getting closer and closer to 0. So let's graph it. At negative 1, you're at a half. At negative 2, you're at a quarter. Negative 3, even less than that. And it's getting closer and closer to 0 here. So graphically, this shoots on up towards infinity here. And then this actually gets closer to 0. So you can kind of make it look like a horizontal line there. All right, let's answer some questions about it. It now is saying, is the base of the exponent less than 1 but greater than 0? Or is it greater than 1? All right, well, for the equation that we're looking at, it was this guy, y equaling 2 to the x. The base is the 2 right there. So it's just asking, is 2 a number between 0 and 1, or is it greater than 1? Well, that's greater than 1. Is the function decreasing or increasing? As a little reminder, remember, you read the graph from left to right, just like you're reading a book. So from left to right, the function is going up. That means it is increasing. All right, end behavior. We've seen a bunch of practice with this. As x goes to infinity, so as I look to the right on the graph, where's y going? Well, y is going up. And so if I can say that y is going up, it's heading towards infinity. All right, as x goes to negative infinity, so as we look to the left on the graph, going this way, where's y going? Well, y, oddly enough, is heading towards 0. So that's the answers to the first one. What I would like is that you were able to complete the next few on your own. So what I am expecting, I'm going to flip my page on over here, is you're going to change what you have in your y equals. So you can go up top, clear that out, and then put in 1/2 and raise it to the x power. And then you're going to go to the table. And if you need to, you can retype the values in. Otherwise, you can see some of them are already here, but you can type right over the top. So record them. And keep in mind, you're only taking it to these bigger numbers so you can see the trend. Like, where is it going? Is it heading to infinity? Is it heading to maybe negative infinity? Is it heading to 0? And so on. And then you're going to sketch what you come up with over here. Then you're going to answer these questions based on the equation. So if you have 1/2 to the x power, remember, this part is the base. Which category does it fit into? Then look at your graph. Is it decreasing or increasing? And answer for your end behavior. So you're going to do part B, part C, and then there's one more part D here on your own. When we hit class tomorrow, we are then going to do the summary together. So we'll do this in class. If you'd like to see if you can answer some of this on your own, go for it. That would be awesome. Otherwise, you're working on parts B, C, and D, and then I will see you guys in class to talk about the rest. Thank you.